forming differential equation for a given curve. Okay. So in this exercise, what they will do is they'll give you a curve and we need to form the differential equation for it. For example, form differential equation for the curve x square by a square plus y square by b square is equal to 1. Or I'll make it even simpler. It is x square plus y square is equal to a square. Okay. So when I say forming a differential equation, this is a solution of some differential equation. Okay. So is this a general solution or a particular solution?
General.
Why are you saying it's a general?
Because it doesn't have a value, it's a standard equation.
Given a constant.
It has an arbitrary constant. Means the value of the equation will change as you keep changing the value of a. Right? It's a general equation. Because how many arbitrary constants does it have?
One.
One arbitrary constant. So remember, the number of arbitrary constants present in the question is equal to the number of times we need to differentiate. Remember, number of arbitrary constants is equal to number of times we need to differentiate. So if that is the case, then when you differentiate this implicit function once, what do you get? You get 2x plus 2y y dash is equal to derivative of a square is 0. It's a constant, but it's some arbitrary constant, right? So it is going to be 0. So 2 and 2 will get cancelled, which implies x is equal to minus y dash, which implies y dash is equal to minus x divided by y. Right? What did we do? We wrote the differential equation. dy by dx is equal to minus x by y. This kind of an equation we have seen in applications of derivatives itself when we solve problems based on tangents and normals. Do you remember? So according to applications of derivatives, what did we find? What have we found here? This is slope of
tangent.
It is a slope of the tangent that we have found. Okay. So in the case whenever this kind of an equation is given, when you differentiate and find dy by dx, you're actually finding the slope of the tangent. But in this context, in this chapter's context, what did we find? We found the required differential equation. So the required differential equation for x square plus y square is equal to a square is given as y dash is equal to minus x divided by y. Okay, so this is where you need to stop it. So there is the required differential equation. Shall we do one more problem? So what form the equation? We need to check arbitrary constant, right? So how many are there? We have arbitrary constant, so always take constant to be 1. Then dy by dx d square y by dx square will be equal to 0. So this would be the required differential equation. Did you understand why I differentiated twice? Why is no one speaking?
second order derivative test.
So there are two arbitrary
Not
constants.
second. It's because there are two arbitrary constants. That's the only thing. In this context, we are not going to do any derivative test. Number of arbitrary constant is equal to number of times we are. Okay. Similarly, let's take an example number 3. Form the differential equation for the curve x squared by a square plus y squared by b square is equal to 1. So what is this?
Ellipse.
The ellipse, right? We need to. So how many arbitrary constants? Look for it. 2. So we need to differentiate it twice. So differentiating on both sides, what do we get? Let this be equation number 1. When you differentiate on both sides, you get 2x divided by a square plus 2y into y dash divided by b square is equal to 0. Yes or no?
Yes.
So 2x by a square plus 2y into y dash divided by b square is 0. So we need to again differentiate it. When you differentiate it again, 2 divided by a square plus, what do you get? 2 divided by b square into y into y double dash plus y dash into y dash. I've applied UV rule. This will be equal to 0. So 2 by a square plus 2 by b square into y double dash plus y dash square is equal to this be equation number 3. So what we need to do here is from 2, y dash is how much? From 2, what is y dash?
XB square
Or
by
what
a
we
square y.
or wait, I'll tell you a simpler method. From 2, see our work, the reason why we are differentiating it twice is because we need to eliminate the arbitrary constant. That is our whole objective. Okay. So when that should happen, from 2 can I write it like this? 2 divided by b square is equal to, or I can take 2 divided by a square itself. So 2 divided by a square will be equal to 2 into y dash divided by b square into 1 by x. Did you understand what I did?
Yes, sir.
Sir, minus, will it become
minus, sir.
Yeah, minus it there. Yeah. Okay. So let me call this as star. So in the place of 2 divided by a square, what can I do? Minus 2y dash divided by b square into 1 by x plus 2 divided by b square into y double dash plus y dash square will be equal to 0. So b square gets cancelled. What is that you're left out with? 2 is also going to get cancelled. Y dash divided by x is equal to y dash plus y dash square. So when you rearrange it, this is one of the ways in which you can write the differential equation. Did you understand?
Yes, sir.
Y double dash. So this is what we need to do in this particular exercise. Okay. So to my knowledge, they have actually deleted this from your exercise from your syllabus for this year. But this is the outline. The reason I've explained this is because whenever you're forming a differential equation, you need to understand how many arbitrary constants are going to come. So this exercise, I've explained the outline part. What you need to do is you can try all these problems irrespective of the syllabus so that you will have good practice of differentiation as well as understanding of how to solve the next exercises. Okay. So this part I'm leaving it to you.